We move on to another method that we use when we add vectors, which is to use the analytic method. This is called the analytic method for vector addition. So each vector, like this vector A, can be decomposed into two components, x and y. This is the x component. We can calculate it using trigonometry. Ax equals A, magnitude of A multiplied by cosine theta, and Ay equals A multiplied by sine theta, because this length is the same as this length. So from this triangle, this length AY is equal to A sine theta. So we can express A in terms of these two components. The magnitude of Ax, we know it, Ax cosine theta, the direction is along X, and for Y, the magnitude is A sine theta, and it's along the direction of Y. This is useful when you have many vectors to deal with. It's easier than graphing. You don't need to use protractor and meter stick. You can do the work mathematically. Okay. So you need just to take note of this, how we calculate Ax, how we calculate Ay using trigonometry. And you apply the same principle for any other vector if you are trying to decompose them. And you can always go backward. The resultant A is equal to square root of Ax squared plus Ay squared, applying the Pythagorean theorem. And the direction theta is equal to tan inverse Ay divided by Ax. So this way you can determine the resultant, and also you can determine the direction of the resultant. So whether you have the vector in terms of its components or whether you have it in terms of its full length and direction, either way, you know how to relate them to each other and how to move from one representation to the other. Okay. This is just to tell us that Ax is A cosine theta when theta is taken between the vector and the x-axis. But if you take theta between the y-axis and the vector, then Ax is A sine theta and Ay is A cosine theta. Okay? So you need to be aware of this. When we say Ax is A cosine theta, this is if theta is between the x-axis and the vector. Okay? Keep this in mind when you decompose vectors. In this figure, we have two vectors lying in the xy plane. What are the signs of x and y components? Okay. So if you decompose A, Ax will be along this direction. This is minus x. Ay would be along this direction. This is positive y. Then for B, when you decompose it, Bx will be along the positive x and By will be along the negative y axis. Okay. If you want to add, you can displace B. This is B. The same magnitude, the same direction as we did nothing, but the bottom of B is on the tip of A, so this would be the resultant. This is how we add the two vectors A plus B. Which vector has an angle with respect to the positive x-axis that is in the range of the inverse tangent function? As you know from arithmetics, the range for the inverse tangent function usually means the angles between minus pi over 2 and plus pi over 2, which means the first and fourth quadrant. Okay, we see that B is in the fourth quadrant. A is in the second quadrant, so it does not belong to the inverse, to the range of inverse tangent function. So to add vectors, you can do that graphically, as I explained, or you can do that analytically by decomposing the vectors. If you decompose the vectors, you add the x components together, ax plus bx to give you rx, and ay to by to give you ry. Then you say r equals rx plus ry square under the square root. When you solve problems, it is important first to read and understand the problem. 50% of the effort usually in understanding the problem, because if you do not understand it right, you have small chance of getting the right answer. So you need to read, digest, comprehend, understand. It helps you to draw a sketch for the problem. Then it is good to label the physical quantities. If you are talking displacement, you are talking velocity, it is helpful to label the diagram with the proper variable. You identify from the text of the problem, you identify the given variable to you. Then you know how to relate these variables. You need to choose the right equations to plug in the numbers and do some algebra to solve the equation. Once you have the answers, you check them whether they make sense or whether they are nonsense. So it's a good and simple strategy, but my advice to you, try to solve as much problem as you can in physics by solving problems. This is the best way to learn physics. You need to practice solving problems as much as you can. So in this chapter, we learned about the standards of length, mass, and time. We learned about matter. We learned about measurements in general. We learned about few techniques that we use to check on things like dimensional analysis. Any equation to be correct, the dimension both left and right sides need to be the same. We learned about significant figures, how we represent the result for any measurement that we do. We learned how to convert between the systems of units and how to estimate the order of magnitudes for our results. We learned about coordinate system that we need to describe the location of any object, whether it is at rest or whether it's in motion. We learned about the Cartesian coordinates and the polar coordinates. We learned how to go from one system to another. So x is r cosine theta and y is r sine theta. This is how we move from polar to Cartesian coordinates. We also reviewed the basic trigonometric functions, the sine, the cosine, and the tangent, also the Pythagorean theorem. We learned about vectors, how to add them, how to subtract them, how to multiply them, and divide them.